Hey everyone, I said I'd create a video where I continue to show you how to do some simple things to put together this Asteroids demo we started in class. So I made a list of everything I still want to accomplish with this demo. First of all, I have to fix a memory leak that exists in our program that's very important. Then I want to improve the asteroid behavior. Then we want to be able to shoot bullets, make sure we don't have any memory leaks doing that. And then we want to implement collision detection. So let's start with fixing that memory leak. So here's what we have so far. I'll just play the game. Okay, we've got asteroids coming down the center of the screen, and we have a ship that we can control, and the ship can't leave the screen. That works out great. The problem we have is that we have something called a memory leak. We keep spawning all of these asteroids, but they never are removed from the game, and each asteroid is taking up space in memory. It's taking up RAM. So we're getting to have hundreds, possibly thousands of asteroids that are being simulated that are completely off the screen and should be out of the game at that point. I'm going to open up game1.cs. We're going to take a look at the problem in there. So I'm going to go down to the update method. Alright, and in the update method we have this bit of code right here. Okay, this line of code creates our new asteroid, and we put it in a variable, a temporary variable called A, and then we add it to our list of asteroids. And I want to show you exactly how I can tell that we have too many, or that we're not removing asteroids after they go off the screen. So to do that, I'm going to do a console.writeLine, which is basically a way of helping us debug our program. So I'm going to have the write line say number of asteroids, and then I'm going to concatenate with that string the actual number of asteroids, which I can get by grabbing the asteroids list and then grabbing one of its methods called count. Now count always tells me how many asteroids there are, or rather how many objects are in the asteroids array. So this console.writeLine should output about 60 times a second, and it should be telling me exactly how many asteroids I have. So if I hit F5, my program will recompile, and here it is running. So where's this console.writeLine outputting to? Well, if you can find your output panel, it's outputting right there. And you'll see at this point I have over 800, now I have 900, now I have 1,000 asteroids. So what we have to do is make sure that our game is able to remove asteroids once we're done with them. I'm going to stop my program, make sure that's not running, and we can get rid of this line of code, or you can comment it out, whatever you want to do. Now, when we're building games, we typically want to create new objects on the fly while the game is running, and that's what we're doing right here. And we also want to be able to remove them. So the way I do it is I add a property to objects that I can use to track whether or not I'm done with that object. So I'm going to go into the asteroid class. Right now it has a property called speed. I'm going to add another property. Okay, and this property is going to keep track of whether or not I'm done with this object. And so its data type should be a Boolean, and I like to call this dead. Now by default, the asteroid isn't dead when it's created, so I set it to false. Once I set this dead property to true, the game1 class will realize that, and it will remove the dead asteroid. This is something called a state machine. It's a variable that keeps track of the state of an object. And in this case, the state is either it's dead or it's alive. So when do we mark it as dead? Well, in this case it's very simple. In the asteroids update, we can say if the asteroid has gone off the bottom of the screen, then it's dead. Well, how do we know if it's gone off the bottom of the screen? Well, that's just a simple comparison of numbers. If its y value is greater than the height of the screen, then it's gone off the bottom. So in the update, we can say if position.y, if that number is greater than the height of the screen. So maybe you don't remember the height of the screen. It's actually 480. And I'll type in 480 here. If position.y is greater than 480, then dead equals true. So this alone isn't going to fix the memory leak. We now actually have to do something if asteroids are dead. Now specifically what we have to do is we have to remove the asteroid object from the list that it's inside of. And that's not going to happen inside the asteroid class, because the list isn't in the asteroid class, it's in the game1 class. So jump back out to the game1 class, and what we need to do is every update, we need to look at every asteroid and see whether or not it's dead. Okay, now that means if we're going to look at every single asteroid, we have to loop through our asteroids array. And we could create a for loop that loops through all the asteroids, but we already have one, and it would kind of be redundant, and it would slow our program down if we created another for loop to loop through all the asteroids. So what I'm going to do is have a for loop that loops through all of the asteroids, then it updates all the asteroids while it's looping, and then after it updates a given asteroid, it's going to check to see if that asteroid is dead. So we can say if asteroid, or asteroids, if asteroid number I dot dead equals true, I need a double equal sign there, then we're going to remove it. Okay, I do have one compiler error here, and it's that I can't access dead. Dead is by default private, so I just gotta have to jump back to asteroid, make sure my dead property is public. Okay, so now that compiler error is gone. If asteroids number I is dead, or rather if dead is true, then we remove it from the list. We add new objects to the list with the add method, and we can remove them using the remove method. So we can say asteroids.remove, and we can do this a couple different ways. We can say remove, remove all, remove at, or remove range. If we say remove, we give it an asteroid to remove. So I could say, for example, asteroids number I. Now, this would work perfectly fine, but this is probably more complex on the processor. And that's because if we're giving it a specific asteroid, it then has to, behind the scenes, loop through the entire array looking for that exact asteroid. What we can do instead is call the remove at method. The remove at method just wants a number. It wants an index number. And we already have the index number. We're looking at asteroid number I. This way, on the back end, it doesn't have to loop through the array, or at least I assume it doesn't. And this is probably a more efficient way to go. Okay, so what we can do is run our program, make sure it compiles, make sure everything still works. And it looks like it does. It's hard to tell because nothing really looks any different. So what I want to do actually is bring back that console.write line and see if my asteroids just continue to grow indefinitely or if they actually stop at some point because asteroids are being removed. So I'll say number of asteroids, then I'll concatenate that with asteroids dot count. Now I'll compile it, and I'll check out my output panel, and look at that. If you can't see, my output panel is saying I have 49 asteroids. So what happens is that they're spawning consistently and they're being deleted consistently. So at a certain point, it hits a terminal amount. It hits 49 that it doesn't go above. If I were to scroll all the way to the top of this output window, you'd see it starts at 1 and it counts all the way up to 49. So that's a pretty good indicator that we are removing the asteroids. So since we are no longer using an asteroid, since it no longer has a variable pointing to it, it's going to be removed from memory, and that memory is going to be cleared out by something called the garbage collector. And we'll talk more about that in class because we're going to be removing dead objects from all of our games because we don't want to create memory leaks. Okay, so that pretty much takes care of step number 1, fixing the memory leak. Next, I want to improve our asteroid behavior. I want our asteroids to not come down in a single file line. So inside the asteroid class, what we're going to do is in the asteroid constructor, we're going to set the position's x value to be a random number. Okay. Now, in order for us to generate random numbers, we need a random number generator. And what I'm going to do is create one for the class. I'll say random equals a new random. The random class is a random number generator, and lowercase r random is my property for the random number generator. Now, to get a new random number, we say random.next, and that's going to give us an integer. And with next, we can specify a minimum and a maximum number. So this is going to generate a random number between 0 and 800. Now, if you try to run this, it's not going to work. And the reason why it's not working is because position.x actually refers to the property, or not the property, the variable position that gets passed in here as a parameter of this method. What we want is the property in the sprite class called position. So we're going to say this.position.x equals random.next. If we do that, yes, we have asteroids all over the place. And that's great. I'm going to suggest one improvement here, though. And what this is doing is it's giving every single asteroid that spawns a random number generator. And that's actually going to be taking up more memory than is really necessary. What we can do is give the asteroid class one random number generator that all of the asteroids share. And that's kind of what the static keyword does. So if we make the random property a static property, only one is ever created, and then it's shared by all of the asteroids. There really is no difference at runtime, but there should be an improvement to the program's memory footprint. Okay, so some improvements here. You'll notice that if you watch the asteroids come down the screen, they kind of pop in at the top and then they pop out at the bottom. And what I'd love to have happen is for them to slide in at the top of the screen and then completely slide out at the bottom of the screen before they disappear. So what we can do is make it so that their starting y value is up off the top of the screen. So you kind of have to know the dimensions of the image, and the asteroid image that we're using, if it wants to open in Paint. Oh wow, I don't know why it opened in Paint. I don't even know how to use Paint because Paint is dumb. Well, it's about 100 pixels tall. I don't know where it says it in there. So really we have to move it about negative, 50 pixels up off the top of the screen. Or we could be safe and just move it, say, negative 100 pixels up off the top of the screen. If we try that, now they slide in at the top, but they're still popping out at the bottom. And what we have to do is have them move further down before we set dead to true. So let's remove them if they go past 550. And there we go. So they're not popping in at the top and they're not popping out at the bottom. This is pretty good. However, it may be too many asteroids. So if that's the case, what we have to do is play around with how often we're spawning asteroids. If we're assuming the game is running at 60 frames per second, then we're generating 60 asteroids every second. So what can we do to fix this? Well, in the Game 1 class, we're spawning an asteroid every single update, which is why we have the 60 or so per second. What we want to do is not generate an asteroid every second, or every update, I mean. We can do this one of a couple different ways. We can use a random number generator and say, for example, there's a 10% chance to generate asteroids. And that would work decently. The other thing we can do is keep track of how many frames have gone by and only spawn an asteroid every 10 frames or so. So I like that second method. It's really easy to implement. What we need to do is we need to keep track of how many frames have gone by. In order to do that, we need a variable. So I'm going to go up to the top of the game1 class, and I'm going to create a property. It'll be an integer, and I'm going to call it counter spawn and set it equal to 0. Counter spawn. Now down in the update, what I can do is say if counter spawn is less than 0, then we're going to spawn a new asteroid. Or you could say less than or equal to 0. And then every time we spawn a new asteroid, set counter spawn to be 10. And then make sure every single frame you just subtract 1 from counter spawn. So now it's constantly counting down. Now why do I count down instead of counting up? Well, it's easier to actually change your threshold if you're counting down. See this counter spawn right here? If we change it to 20 instead of 10, now we've just doubled the delay. So I'm going to run it at 20, and you can see that's how many asteroids we get now. If I reduce it to 10, you'll see we'll get asteroids twice as often. And basically you can play around with that until you have the speed you want. Now another improvement we can make to the asteroid's behavior would be to change or to randomize the asteroid speed. Right now they're all moving at the same speed, and that kind of looks like crap. So jump over to the asteroid class where we have a speed property for each asteroid, and in the asteroids constructor we'll just set the speed to be a random number. So we could say speed dot y equals a random number, which we can get by saying random.next. We could say a random number between 1 and 10. And if we try that, I think that's much more interesting. Now that the asteroids are moving slowly, you might notice that occasionally they jump a little bit. One or two of them every once in a while look like they aren't getting updated. And that's actually true. We do have a bug that I forgot to point out in our when we were fixing the memory leak. So just to backtrack real quick, I'm going to go back to the game1 class. I'm going to go to where we are removing asteroids. What's happening, and I'm going to explain this a little better in class, but what's happening is that when we remove a dead asteroid from an array, if we're counting up in the array, what ends up happening is we end up skipping updating the next asteroid. Okay, that's a pretty significant bug that can cause a couple issues in your program, but most of all it just kind of looks annoying to have asteroids that don't always update. The trick here, the easiest way to deal with this, would be to count down instead of counting up. So how do you count down in a for loop? Well, instead of starting at 0, we're going to start I at asteroids.count minus 1. That is the highest index number available inside of this list. It's asteroids.count minus 1. And then we're going to run the for loop while I is greater than or equal to 0. Okay, because one of the possible index numbers is 0. So we have to say, well, I is greater than or equal to 0. And then, of course, we have to subtract from I instead of add to I, so that we're counting down. So now I've just rewritten this for loop so that it counts down instead of up. And if you run your program now, you won't get the asteroids looking like they're ever jumping, because now they're always being updated. Okay. Other possible improvements to the asteroids, we can add sideways movement. So just to show you what that could look like, I could say speed dot x equals a random number between -2 and +2. And now they've got a bit of sideways movement. We could also play around with the scale or the rotation. For today, I'm just going to show you the rotation. We're going to say rotation equals a random number. And remember that rotation is measured in radians, not in degrees. So let's just generate a random number between -3 and 3. This is actually, like I said, random.next is going to give us an integer. So they're not going to be at any angle. They're going to be at one of 6 different angles. And that's okay. I would much rather generate a floating point number instead of an integer. But in this case, it doesn't really matter. The other thing that would be nice is if the asteroids were actually rotating as well. Well, what we want to do for that is add a new property to the asteroid class. We currently have a speed property, but that's speed for x and y movement. What we need is a speed property for rotational movement. Well, we need a speed property for rotation. So that's going to be a float, and I'm going to call it speed r, and I'll set it equal to 0. Then every single update, just like we say position plus equal speed, we'll say rotation plus equal speed r. No, they're not going to rotate right now because speed r is 0. So let's set speed r to be a random number. Speed r equals random.next, and this is not going to work for us. Let me just choose a random number between 1 and 2. Now, a couple different things you should know here. Random.next, like I said, it gives you an integer, and if you give it a minimum and a maximum, what it's actually doing is the minimum number is inclusive and the maximum number is exclusive. So this is actually going to give us 1 or 1. It's only going to give us 1 because it'll never give us 2. If I make this 1 to 3, it'll actually give me 1 or 2, but not 3. In any case, just hit F5, and you'll see that these numbers are way too fast for rotation. And again, that's because what you're doing here is you're telling it to spin at 1 or 2 radians per update, which the game is updated 60 times a second, and that's just way too fast. What we want to do is generate a much smaller number. So I'm going to call the next double method. The next double method gives us a number between 0 and 1, and of course returns a double. I have a compiler error here, and that's because speed r needs to be a float. So if I just cast the result of next double as a float, then we're good to go. Okay, so they're not spinning as fast, some of them anyway, but that random number is sometimes close to 1. So the objects are sometimes spinning at about 1 radian per update. That's still too fast. What I want is a number between -0.1 and +0.1 for my rotational speed. And here's a little trick. When you're generating a range of random numbers, what you want to do is take the number that's between 0 and 1 and multiply it by your full range. So the range from -0.1 to +0.1 is 0.2. So I'll multiply the double by 0.2f, and then you want to add your minimum number to this. So my minimum number is actually -0.1f. So if I do that, I'm going to get a number between -0.1 and +0.1. And now I've got objects that are spinning clockwise, they're spinning counterclockwise, and they're not too insanely fast. Now the other thing you could play around with is you could play around with scale, but I'm not going to do that today because affecting the scale of the object is going to involve a little bit more thought when we get to collision detection, and I just don't feel like doing that right now. So for now, we're going to consider step number 2 to be complete. We improved the asteroid's behavior. Now we want our ship to shoot bullets. Well, we're going to need a bullet class. We don't have one. So I want you to come over here and right-click on your project and say Add Class. And we're going to name the class bullet. Please remember to name that with a capital B, bullet.cs. And here's our class so far. Now, first thing you probably want to do is copy in the using statements so that we can get access to the XNA framework. So just highlight all of those, say copy, and then paste them in the bullet class. Then you probably want to tell the bullet class to be a subclass of sprite. And then we want to write a constructor for bullet that properly calls the sprite constructor. So for that, I'll just copy the declaration of the asteroid constructor. Oops, I'll paste it in. Make sure I change this to say bullet. Okay. There we go. Now before actually creating any bullets, I'm just going to hit F5, make sure my program compiles. If it compiles, I didn't make any mistakes yet. Good. Okay, so how can we improve this bullet class? Or how can we just go about creating it? Well, a bullet it has to be able to move. So that's usually a pretty clear indication to me that I need to give it a speed. And speed is going to be a vector 2. And by default, I'll just say it equals new vector 2, 0, 0. If an object has speed, it probably needs to update from time to time. So I'll say public void update. And every update, we should be adding the speed to the adding the speed to the object's position. All right. Now, by default, I'll just make the speed 0. I said a moment ago I do 0, 0, but let's do 0, negative 10. Now, back to the game 1 class. When the player is holding the spacebar button, I want my ship to shoot bullets. So I'm going to, in the update, I'm going to come up here, and I have to get the current state of the keyboard if I want to see if the spacebar is pressed. So just like we did in the ship class, we're going to say keyboard state, ks, equals keyboard.getState. From there, we can now say if ks dot is key down, keys dot space, and open up a new block. So if the spacebar is being held down, whatever is in this block will run. So this is where we can spawn the new bullets. Now, before we can spawn bullets, we need to have an array, or rather a list, that can hold all of the bullets, just like we have a list of asteroids. So scroll up to the top of the game 1 class, and let's create a list of bullet objects that I'll call bullets. And there we go. Now we can create a new bullet and we can add it to our list of bullets. So bullet B equals a new bullet, and what we need for this bullet is we need to give it a texture and a position. So we'll just load up using the content manager and content.load a new texture 2D by the name of bullet. So I'm now loading the bullet texture, and I'm passing it into the bullet class, and we have to also pass in the position that we want the bullet to start at. And we want the bullet to start on the same position on the screen as the ship. So we'll just say ship.position, and we'll see how that looks. Now before we go any further, we want to make sure we add this bullet to our list of bullets. So we say bullets.add B, and there we go. So this is going to spawn new bullets when the space key is pressed. But we have to do two things. We have to update all of our bullets, and we have to draw all of our bullets. So right here we've got this for loop, and this for loop updates all of our asteroids. We want to do something very similar for all of our bullets. Now I'm going to say for int I, And with a little bit of forethought here, we can realize that our bullets also need to be able to die, and we need to be able to remove them from the bullets list eventually. So instead of counting up our bullets in our bullets array, we're actually going to count down. So we're going to say int I equals bullets.count minus 1. We're going to run the array we're going to run the for loop while I is greater than or equal to 0, and we're going to subtract from I. Then we can say bullets I.update, and that will of course update bullet number I, and since we're looping through the entire list, it'll update all of the bullets. And we're going to come back to this later, and we're going to remove dead bullets. So let's go down to draw and make sure we draw all of our bullets. I'm just going to use a for each down here. I'm going to say for each bullet B that is in the bullets array. I keep saying array, but I think you know I mean list. B.draw sprite batch. Alright, let's see if this works. I'm going to hit F5, and when you hold down spacebar, your ship shoots bullets. That's pretty cool. Notice the bullets spawn from the center point of the ship. Also notice that when your ship turns, that does not affect the direction that the bullets move in. And of course there's no collision detection yet. So from here, let's make a couple changes to the bullet class. First of all, I want to make sure that we don't have a memory leak in our program. We want to make sure that our bullets can die just like our asteroids can die. So I'm going to create a public boolean called dead and set it equal to false. This is our finite state machine that keeps track of the state dead. And then in update, we want to set dead to true if we're done with the object. Well, we're done with the object if it goes off the top of the screen, but not all of the bullets move up. Well, I mean, they do now, but if our ship can turn left or right and shoot the bullets left or right, we need to be able to make sure those objects are dead if they go off the left or the right side of the screen. So we could say if position dot y is less than -10, dead equals true. We could say if position dot y is greater than 490, dead equals true. If position dot x is less than -10, dead is true. And if position dot x is greater than 810, dead is true. Alright, that handles all 4 directions. Back in our game 1 class, in the update method where we are updating the bullets, we're going to say if bullets number I dot dead equals true, then bullets dot remove at, and we're going to remove bullet number I. Okay. So we have some memory management here, or rather we don't have a memory leak. The next big step would be to get the bullets to move in the direction that the ship is facing. Okay, so let's get our bullets to move in the direction that our ship is facing. To do that, we need to set this speed x and speed y property for each bullet. And the speed x and speed y actually have to reflect the angle that the ship is pointed in. So this is can sound really difficult, but we're just going to use some trigonometry to do that. So when we create the bullets, we then want to set the bullet speed. And we could do this a couple different ways. We can access the speed property right here in the game 1 class. Or we could pass in a speed or rotation value into the constructor for the new bullet. And actually, let's just pass in the angle that we want the bullet to move in into the constructor. Well, the angle we want the bullet to move in is probably the ship's rotation value. So I'm going to say ship.rotation, I'm going to pass that in as the third parameter for this bullet constructor. Now, of course, I've got a compiler error here, and that's because the actual constructor in the bullet class doesn't contain 3 parameters or 3 arguments. So let's go fix that. In the bullet class, here's the constructor. It's got a texture2D argument and a vector2 argument. And let's add a third one for angle. Okay, so when the bullet gets constructed, we want to set the speed x and speed y based off of the angle that gets passed in. So basically, we're going to say speed.x equals some speed constant. So if we want the bullet to move, let's say 10 pixels per update, we'll just type in 10 here. And then we'll multiply that by the cosine of the angle. And remembering here that the angle, of course, is in radians, but it gets passed in as radians anyway, so we're all good. Now, I do have a compiler error here, and that's because math.cosine returns a double, and speed.x is a float. What I'm going to do is throw parentheses around this entire thing over here, and then I'm going to cast it as a float. Now I'm just going to copy this line of code and paste it because that's faster than typing the whole thing again. And I'm going to change it so that it says speed.y equals 10 times the sine of the angle. And that should be good. Let's give it a try. I'm going to hit F5. And notice that it does respond to the angle the ship is facing. However, it is 90 degrees off. And if you were in class, you'll remember that we talked about this. That's because in this environment, in most environments, 0 degrees is directly to the right. And when our ship is rotated 0 degrees, the image of the ship is actually pointed up. So really the easiest way to fix this would be to subtract 90 degrees from the ship's rotation when we pass in an angle value to the bullet constructor. So in the game1 class, when we create a new bullet, instead of passing in the ship's rotation, we're going to pass in the ship's rotation minus 90 degrees. But of course, we want to remember here that the angle needs to be in radians and not degrees. So what is 90 degrees in radians? It is pi divided by 2. So we can say math.pi divided by 2. Now I do have a compiler error here. That's because math.pi is a double. And if you remember, my bullet constructor expects a float to be passed in for the angle. Now, I could cast math.pi as a float, or I could just allow it to pass in a double instead of a float to the constructor here, and then we're good to go. Let's try that. I'm going to hit F5, and notice that now the bullets, they're going to shoot in whatever direction my ship is facing. However, you might also notice that the bullets are coming from the center of the ship, and we want them to come probably from the top part of the ship. So what we want to do is we want to move them forward on their path. Basically, if you want to count 1, 2, 3, 4, 5, 6, about 6 updates down their path. And there are a couple different ways we could do this, but really the easiest way would be to say position plus equal 10, or not 10, 6 times the speed. So basically what we're doing here is we're moving it down its path 6 times. No, we're not. Why not? Oh, I have to say this dot position. If I just say position, we're referencing this position parameter that gets passed in. If we want to access the property, we have to say this dot position. And there we go. Now the bullets are coming out of the front of the ship. Now if you think 10 is too slow for a speed, you can of course change it. You'll want to change it here and here. So now the bullet's going to move at 20 pixels per update. Of course, you probably don't want to update it 6 times then. When it first spawns, you probably want to update it 3 times. So this is something to play around with, but it seems to work pretty well. Now if you want to, you can play with your your logic so that holding down the space bar doesn't allow us just to shoot bullets infinitely, because that'll make the game a little bit too easy. You can change your logic so that you actually have to tap the space bar to shoot the bullets. And if you've taken a class with me in the past, you might remember how to do this. Basically, what you have to do is store the state of the space bar from the previous update. So you want to know if the user just tapped the space bar. If they just tapped the space bar, the value, let me show you real quick, the value here will be true, but the previous value should be false. So the space bar went from not being pressed to being pressed. I'll let you figure out how to do that. In the meantime, so our ship shoots bullets, and we took the steps to make sure that the bullets are removed from the game, so we should have no memory leaks. The last thing I want to do is, for this demo, is do some collision detection. So I want to make it so that I test to see whether or not every single bullet, or any bullet, is colliding with any asteroid. So what I have to do is loop through every single bullet and loop through every single asteroid, and I have to do this as a nested loop. So since we're looping through asteroids first, I'm going to do it inside of this asteroids for loop right here. So what we're going to do is we're going to update asteroid I inside this loop. We've already done that. And then we're going to loop through every single bullet and get the distance between each bullet and this asteroid number I. If that distance is too small, then the objects must be colliding. So what I'm going to do is create a for loop here, and I'll just use a for each loop since that's pretty easy to do. I'll say for each bullet B that is in the bullets list, do this loop. So I want to get the distance between bullet B and asteroids number I. Well, to do that, we're going to use a formula called the Pythagorean theorem. And if you don't know it, you're going to want to get pretty comfortable with it, because it's a really great way to do collision detection, or simple circular collision detection for games like this. But here's how I like to do it. I like to say find the distance x between the two objects. So that would be b.position.x minus asteroids number I.position.x. And then I'm just going to copy this line of code and paste it. It'll be a little easier than rewriting the whole thing. Distance y between the two is going to be b.position.y minus asteroids I.position.y. So now I have the distance on the x-axis and the distance on the y-axis between these two objects. If I want to find the literal distance between them, I have to do the Pythagorean theorem. And I'll just store that in a variable called dis, and that will equal the square root, math.square root, of dx squared, so dx times dx, plus dy squared, dy times dy. And I do have a compiler error here. That's because math.square root returns a double, and I'm trying to store it in a float. So either I could change my data type here to be a double, or I could just cast this as a float. Either way. Okay, so now this tells me the distance between the two objects. But when are they colliding? Well, to know that, we have to know about how large the asteroid is in pixels, and we have to know about how large the bullet is in pixels. I believe most asteroids are about, in this case, 120 pixels wide. So if we were to put them inside a circle, that circle would have a radius of about 60 pixels. And the bullet is, I don't know how large because it's opening in paint. That is really obnoxious. What I'm going to do actually is right-click on bullet.png, and I wish it gave me the option to see the file. But I'm just going to navigate to the file in Windows, select it, and it tells me the bullet is 11 by 11. So the radius of the bullet is about 5 to 6. Yeah, and we'll use 60 for the asteroid's radius. So what that means is the minimum distance these two objects can be apart from each other, would be their two radii added together. So if the asteroid is about 60 or 55 or so, and the bullet is about 5 or 6, the minimum distance that these two can be apart from each other without colliding is in the neighborhood of 60 to 70 pixels. So I'm going to say if the distance between the two objects is less than or equal to 65, then there's a collision. And what do we want to do in the event of a collision? Well, we probably want to set the bullet's dead property to true. And we probably want to set the asteroid's dead property to true. All right. Let's see if that works. Sure enough, it does. If a bullet hits an asteroid, the bullet disappears, the asteroid disappears, and your ship's doing great. So from here, you can add whatever features you want to add. You need to change the artwork. You can add particle effects. You can make the asteroids come in from all 4 directions instead of just the top. You might want to play around with the speed of the ship, the speed which it turns, the speed of the asteroids, the scale of the asteroids. You can add particle effects. I'm not sure if I already said that. There's a lot of things you could add to make this a much more interesting game. You could add health to the player. You could do collision detection between the player and the asteroids, so that if the player hits an asteroid, they lose health. You could even give health to the asteroids, so that when a bullet hits an asteroid, it takes away from the bullet's health, and then once the asteroid's health hits 0, or less than 0, then the asteroid disappears. So there are many different ways you can take this, and I'm really excited to see what you guys do. If you have any questions, of course, you can shoot me an email, and thanks for watching.